welcome to a bonus edition of Cracking the Cryptic, where I'm going to be trying some pencil puzzles today. Now, what is a pencil puzzle? Well, it's basically a little logic problem. And the reason for doing this is that over on the fan Discord server for Cracking the Cryptic, there is one of these published every day, and it's an approachable pencil puzzle. So this is a group of authors, so it's Shye, Jovial, Tyrgannus, Freddie Hand, and Eric Fox. And every day there's a brand new one of these puzzles, normally with a completely new rule set that you've never seen before, with the idea it's sort of a coffee table puzzle. It's something that shouldn't take you more than 5 or 10 minutes to do, but it has a little bit of interesting logic and sort of gets your brain working for the day. Now, originally I was planning to do a weekly video on this series, and I have to say the reason I stopped doing it is that they take me, because I'm so inept, they take me hours to edit them, and that's because, unlike with the Sudoku, where all Sudokus basically are 9 by 9, all of the logic problems, you can see I've preloaded these into the software, but they're all different sizes. So actually, doing this and then putting the rules on is just an absolute mission if you're completely inept, as I am. So I stopped doing the weekly video, for which I apologise. But anyway, what I did was I asked the guys over on Discord, I said, look, for the last few months, can you recommend me puzzles that you're sort of most proud of? And I'll just do a video with those amazing puzzles in. So that's what they did. So today we're going to be having a look at 5 puzzles, one from each of the authors. Now, I have heard only of one of these puzzle types before. So Tyrgannus has done a Battleships puzzle. Now, I do know the rules of Battleships, so I should be quite good at that one, relatively. But Shye's puzzle, which is the first one on the list, is called Uso-One. I've never heard of that in my life. Then we've got Juosan, which is Jovial's puzzle. Now, Juosan, I've not done a logic puzzle that's Juosan, but I did do a Sudoku, I want to say by, it might have been Udakos, it might have been Abid Hawilla, but one of those guys, I think, made a Sudoku that had a Juosan theme. So that's the context in which I've seen Juosan before. Freddie Hand has created a puzzle called Summon, never heard of that. And Eric Fox has created something called Square Jam, which I read the rules of and thought sounded bonkers. So anyway, those are the puzzles we're going to be looking at. Now, what I plan to do today is to actually, one of the great things about this series is that every puzzle has a little example. Now, because I'm unfamiliar with most of these puzzles, I plan to actually do the example as well as the real puzzle today. So we're going to actually have 10 puzzles to do, I suppose, and I hope you'll forgive me for that. But anyway, my recommendation, my strong recommendation, is that you try all these puzzles yourselves. It shouldn't take that long, and I basically guarantee, if you're any sort of puzzler at all, you'll get a lot of pleasure out of them. So with that said, let's get cracking. Let's have a look at Uso-One, which is Shye's puzzle, and the rules are as follows. Shade some cells so that no 2 shaded cells are orthogonally adjacent, and the remaining unshaded cells form one orthogonally connected area. So that's a sort of Hitori type constraint, if you've ever done any Hitori. Clued cells cannot be shaded, and represent the number of shaded cells in the up to 4 cells orthogonal to the clue. However, exactly 1 clue in each region is incorrect. Oh my god. Okay. Right, let's read that again. Shade some cells so that no 2 shaded cells are orthogonally adjacent. I understand that bit. Remaining cells are orthogonally connected. I could look at the example, but I don't want to do that because I want to do the example. If I look at the example, I'm going to know how to solve it, and that's not going to be the point. Clued cells cannot be shaded. So every clue that has a number in it, we can immediately make green. And represent the number of shaded cells in the up to 4 cells orthogonal to the clue. Exactly 1 clue in each region is incorrect. Right, okay. Well, let's just have a go. This is the example. Now, this is where I'm going to have to start moving the things about. So let's move this over here, which hopefully will be approximately the right place, and have a go at the puzzle. So I can see we've got 3 regions. Oh, yes. Now, how do the... Oh, okay. Okay, I don't quite know how to blacken cells, but well, what I do want to do is to greenify all of the clue cells, because that's what it said. Now the 3 clue in the top left must be lying, mustn't it? Because it can only have 2 orthogonal neighbours. So this is a lying clue, which means I can exit. Now that means everything else in its region is a true clue, so the 0 must be true. So those need to be green. The 2 must be true, so that must see 2 black cells. And every black cell can't be orthogonally next to a black cell, so we can do some more greenifying. This 1 clue is now correct, so that can be greened around. And now let's look at the second region then. So this 2 clue at the moment is correct, but I suppose that could be a black cell. So maybe the 0 clue at the moment is correct, but we don't know what that cell is. And the 2 clue, could be correct or incorrect. Okay, I don't quite understand how we do anything with the second region then. Let's look at the bottom region, where we've got, well, if that 3 clue's correct, it's breaking that 1 clue, because we'd have to do that. Oh, in fact, that 3 clue is not correct. I've just seen why. Because if this 3 clue is correct, forget about the 1 clue for a moment, but look, we'd have to do that configuration. And now this little green cell in the corner would be isolated. So that means that's lying, which means this and this are correct. Right, and now we can do connectivity tricks again. Can't have those 2 around this 3, because that cell's going to be a problem. So that means these 2 must be real. One of these is real. Now, do we know this 1 is correct? We do. That 1 is correct, so we can greenify these. We can blacken this to correct the 3. This 2 has to get out. And so now I have to count which is the right clue. So right, that's nice. So this 0 clue is a lie, because that 2 seems to be correct and that 2 seems to be correct. And to make the 0 clue a lie, I've got to put a black cell in here, and then that's got to be green. And then it says complete. That's beautiful. What a lovely little puzzle. I thought it was going to be I didn't think it was going to solve quite as smoothly as that because of the lying element. But let's find the real version of Uso-One now. So this is the big puzzle. So I'm going to reset. How do I reset the time? If I reload the tab, maybe? Yeah, that's done that. So now, well, let's get cracking and see how we get on with this. So that 4 clue must be a lie, because there's only 2 possible. Oh no, let's green. Let's make everything green. Now, good solvers, I mean properly world-class solvers, wouldn't bother with this step because they would visualize it, but little old me does prefer to see what's going on. Now, this 4 is a lie, so that means that 2 is real, which means I can do black cells into those. Everything connected to a black cell must be green, so that's proper Hitori. It's almost like a Hayawaki type puzzle. This 3 must be true then, so that's got to be in. This green's got to get out, so that's got to be green. This 1 clue must be correct because it's the 4 that's wrong in this region, so that's got to be a black cell, and this 3 is correct, so that must have those 2. So we've got some stuff in the grid immediately. This 1 clue's wrong now. It's got 2 black cells next to it, so that gets X'd in, which means this 1 and this 2 are correct. Okay, so I can't put the 2 cells there or I'd break the 1, and that means that cell's got to be in. And then whichever one of these is taken, only one of these 2 will be taken, and that will correct the 1 count. Right, so the 1 mustn't have another black cell above it then. And this is interesting because that's now broken this 0 clue straight away. So that 0 is a liar, which means the 1 is correct. The 3 is correct. Oh, the 2 is correct. Yes, the 2 is correct. So those 2 have got to be black cells, which means, and this green has to get out of the corner. This 2 clue is now, oh, that's correct. No, hang on, I see. Right, this 2 clue is now has a correct count, but it said a clue in every region is a liar. So this has to be made to lie, which means that cell's got to be shaded. which has incorrectified the 0. So now everything else in this region has got to be true. So that requires a black cell here. This 2 clue must be correct, so that requires this. We've got to get this green out now, so that must be unshaded. This 2 clue needs to be correct, so that's shaded. And the 1 clue needs to be correct, so that's unshaded, I want to argue. This 0 clue is incorrect. It's got a black cell next to it. So this 2 clue is correct, so those 2 have got to be in. That's got to be green. Now, what's going on in this region then? We've got... that's really interesting. So hang on, if this cell here, if this was green, both this cell and this cell would be rendered liars as a result. They would both see 0 black cells. So that's not work. We can't have 2 liars in a region. So I think that must be a black cell, which means that these 2 are now correct, and this must be a liar. So if that's a liar, it mustn't only see... Right. Yeah, okay. So now this 3 clue, I think, is constrained. Because I've got to put 3 around it. But if I just put 1 here or 1 here, then I would correct this 1 clue's count, which I mustn't do. So in fact, because I've got to put 3 around this 3, I must put 2 up here to make sure this is incorrect. Now, this green has to get out, so that completely does this bottom region. This 1 clue needs to be correct, so that's got to be in. Now, one of these must be wrong. I don't see how I know which one of those is wrong, actually. I might be missing a trick there. Okay. So where now? What about how do I not know what that cell is? Oh, that's a bit... I might have made a mistake here, I think. This 2 clue is incorrect because it can only have 1 cell around it as a maximum, so that gets an X, which means this 2 clue is correct, so that gets filled in. Then we've got to, for connectivity, make sure that's green. This 0 clue is now correct because this is the wrong one in this region, so those get put in. This 2 clue is correct, so those 2 get put in, which corrects the count for this one, so all of this gets put in. Oh, lovely. Right. Okay, so now let's come back to this cell here, because this cell cannot be telling the truth. Because if it's telling the truth, I've got to put those 2 in, and that hives off a little triangular area in the bottom left of the grid. So that is a liar, which means this 2 is correct, and this 2... yeah, okay. So how could this cell ever be black now? It can't be, because if this is black, once we put either this one in or this one in to correct this one's count, we're hiving off an area in the bottom left from its friends. So that has to be green. Those 2 have to be in. And then we know these 2 clues are correct. So that renders both of those correct. This has to be green to get this green out. And something... Oh, yes, beautiful. That's a beautiful fact. Look at this. If I make this cell black, I'm going to have a wall all the way down the grid, separating the top right from the bottom left. So that has to be green, and that's complete. That's lovely. Shye, that's lovely. What a beautiful puzzle. Wow. Okay, that's why that's been selected for us, is because that's just top quality stuff, isn't it? So let's move on now. I think the next one was Juosan, which I'm not even sure I know what it looks like quite. I think it's lines. Yeah, there we go. Lines. So this one... Well, let's read the rules. This is Jovial's puzzle. Now, she is normally very, very clever at constructing. So let's see what we've got going on here. Place a horizontal or vertical line into each cell, travelling from edge to edge. Okay, so we can sort of see what's going on there in the top of the example, which I mustn't look at too closely. A number in a region represents how many horizontal or vertical lines it contains. Whichever there's at least, what's that mean? Whichever there's at least half of. A number in a region represents how many horizontal. Okay, oh, I see. So, right, because we're placing a line in each cell, the clue total for a region is giving the sort of majority. It's telling you what the majority line is in that. Well, it's not telling you whether it's horizontal or vertical. It's just saying that there are a certain, the majority, whether it's horizontal or vertical, it's giving that count. Okay. There may not exist a run of 3 consecutive cells containing parallel distinct lines anywhere in the grid. Yeah, I remember this. It's a sort of anti-3 in a row rule. Anyway, I think the only way to do this is going to be to have a go at it. So let's find that one. This is the right puzzle. Let's move this over here like that. And let's just see what happens when we click in cells. I see. So if I click in them, they rotate the type of block. So let's have a go at this now. So this 3 clue at the top. Yeah, okay. So if this was 3 vertical struts, that would be 3 distinct parallel lines. So that's not correct. And because there are 3 of the same line type, that gives us the horizontal stretch. Now, I can see something for this 3 clue now, because we know this is 3 of the same type of line, so if all of these were horizontal, then I'd have 3 parallel distinct lines, wouldn't I? So I think all of these have to be vertical. Now this cell now must be horizontal, otherwise we've got 3 parallel lines again. So yeah, it's basically don't make 3 things in a row. Now look, that's got to now be vertical. Oh, so the 4 clue now, I see how this works, yeah. This 4 clue is saying that there are 4 of one type of line in this box. Now we've put 1 of each in, so the other 3 cells here are filled with the same type of line, either all vertical or all horizontal. Now if they were all vertical, we're going to have loads in a row there, so these must all be horizontal. And now we've got to avoid 3 vertical there and 3 vertical there. Now the 1 is saying 1 of each, so that must be horizontal. The 2 is saying the same type of line, so if we had horizontal we'd have 3 in a row, so we must have vertical. The 4, the 4 is just telling us they're all the same. So now look, we've got loads of opportunities for 3 parallel lines in a row, so both of these have to be horizontal. And now, oh I see, now if this 4 was all horizontal, this would break. We'd have this pattern, 3 in a row vertical, so this must all be vertical. There we go. Right, that's lovely. I understand how that one works. This one is fairly intuitive, I think. Oh goodness, so now we've got to move everything around. That should hopefully be approximately correct. I can reload the page, and that should reset the clock as well, which I'm quite keen to do. There we go. Right, let's have a go. So the 3 in the top left is the same logic we did before. That's got to be a horizontal. Yeah, okay. So there's loads of these. With a 3 strip. Well, when I say load, there are actually 2 more. It's always got to be that. Otherwise, it will break. So this 2 now can't be horizontals, or we've got a problem. So those have got to be verticals. Now the 4 can't be verticals, or we're going to have 3 in a row there. So this must be horizontals. Oh, I see how this is working. And now I've got 2 horizontals here. So that must be vertical, that must be vertical, that must be vertical, that must be vertical. Okay, and then I get stuck. Oh dear. Oh, well, I suppose either side of this 3 clue, if this was vertical, we'd have a problem. So that's got to be horizontal. That's got to be horizontal. Oh, now that's interesting. This cell's become interesting. If that's horizontal, I've got 3 in a row. So that's got to be vertical. And now, oh, this is lovely. Right, now look at this 5 clue. Because that's telling us we've got one of each in the box already. So the rest, these other 4 cells have the same type of line in them. So if they were all horizontal, we'd have that pattern. And that's 4 in a row that way. So these must all be vertical. And now we've got to avoid 3 in a row that way. So that's got to be horizontal. This has got to be horizontal. This has got to be horizontal. The 3 here means that's got to be vertical because we've got to have 3 of one type. Okay, and now I'm stuck. Oh, no, I'm not. Look, I've got two horizontals there, so I've got to interrupt the flow of horizontalness. Oh, how am I going to disambiguate that then? Oh, I see. No, I've just got to avoid 3 parallel lines, so that's got to be horizontal, that's got to be vertical. This has got to be horizontal, and this is in a 4, so all of these have got to be horizontal, and now both of these have to be vertical. And look now. This 3 is interesting because it's in a region of size 6. So we know that there are 3 of one type of line and 3 of the other. So that means I forces that pattern, I think. And now if the 4 was horizontal, we'd have 3 in a row. So these are all vertical, which means that's horizontal. And now I've got to avoid 3 in a row here. You could get really quick at this. You could get really quick at this puzzle. Now look at this 3, all the same. So if we have verticals, we've got 3 in a row. So these have all got to be horizontal. Then avoid 3 in a row here. Don't get stuck. No. If the 4s were vertical, we'd have 3 in a row there. So this has all got to be horizontal. Then don't have 3 in a row. Don't have 3 in a row. The 2s must have an equal count of both types of lines. So those must finish. Now we need horizontal there, or we'd have 3 verticals and horizontal here. The 1 count tells us there's 1 of each. Now that's got to be horizontal, or we'd have 3 verticals in a row. And that's got to be vertical, otherwise we'd have 3 horizontals in a row. We'd actually have 4 horizontals in a row. So now look, this cell's got to be vertical, that cell's got to be vertical, and it's this 5 trick again. So we've got 1 of each. The remaining 4 have to be the same. If they were horizontal, we'd have 3 in a row. So everything else is vertical in this 5 cage, which means that's horizontal, that's horizontal. This is vertical to avoid 3 in a row vertically. This is this is vertical to avoid 4 horizontals in a row. Now this has got to be sideways. This has got to be sideways actually. Oh, and that tells us the count of this 5 group. Look, we now know the majority is that way, which forces this. I think we're nearly done with this. That's got to be sideways. Oh yeah, look. We've got 1 of each. The remainder are the same. If they were vertical, we'd have 3 lines in a row. So these have got to be all horizontal. And now this has got to be vertical. That's got to be vertical, or we'd have a problem vertically. Therefore, that's horizontal to correct the count of the 2. If the 3 was horizontal, we'd have 3 in a row in column 1. So it's vertical. Now this is horizontal, or we'd have a problem there. And now this is so clever. This is so clever. That's beautiful. Wow. Wow. Yeah, that's just elegant. That's a very relaxing puzzle, actually. You could do those just, with your brain in a different place, just sort of clicking away. A bit like those, what's it called, Minesweeper or something. Just very, very cool indeed. Now, let's go on to the next one. So what have we got now? Can't remember. I think it was Tyrgannus next, which was something that was the Battleships. So let's find Battleships. Right, I've got to move the rules around. So the rules for this one: place the given fleet of ships into the grid so that no 2 ships are touching, not even diagonally, so it's like a star battle type constraint. Rotating ships is permitted. A clue outside the grid indicates the number of cells in the corresponding row or column that are occupied by ships. Cells with waves cannot be occupied by ship. A given ship segment must be used as the part of a ship that its shape represents. A given ship segment must be used as the part of a ship. I don't quite understand that last bit of the rules, actually. But anyway, I do understand the rules of battleships in general, so let's put this in here. Maybe something like that is going to work. Now, I don't know what the controls are for this, so let me just click on some things. Can I? Oh, I can right click to create C. Right. So let's do the example. Now, my big tip for battleships, if you've never done one of these before, is to count the clues. So you can see in the horizontal, so we've got a 2, a 4 and a 2, which add up to 8. And vertically we've got 2, 1 and 5, which add up to 8 as well. But you can see the ships we've got to place here are 3, well, basically there are 10 ship segments to place. And that means that in the unclued columns and the unclued rows, there are only 2 ship segments that we've got to find. And that might be important, or it might not. Right, so the bottom row here is fairly forced, isn't it? Because we've got to somehow get 5 ship segments into a 6-cell streak using... So we must have the battleship, the 3-cell shape must be horizontal, along with a 2-cell horizontal strip in here, separated by 1 bit of C. Now, given that each... the only way you can do that, therefore, is these are all going to be ships. And we don't know what happens in the middle, but now we do know that all of this row is all completely C, because remember, you can't have a ship touching another ship in any position. Now this 4 clue is forced. This whole column is now, in fact, was this... Oh no, it wasn't available from the start because I put this in. So that is sensible. So now I can just fill in this, make sure everything diagonal to anything is C-ified, if you like. These are forced. Oh, now interestingly, look at the rows now. I've got 1 ship here in this row and 1 ship here in this row. And we said at the start there are 2 unclued ship segments, and we found them. So actually what we could do now, as a little bit of a shortcut, is just C-ify the rest of those rows, because we found the 2 segments. That's got to be ship, look. In fact, what have we got left to place? We've got a 3, a 2 and a 2. So it's only one, there's one 1-cell ship to place. Oh, and that's got to go here. Right, okay, so that was fairly straightforward, actually. Let's go on to the real one. All right, and I'm going to have to move this stuff around again. Actually, that works quite well there. And let's get cracking with this one. So immediately I'm seeing 0. But what I should probably do, I know I'm going to do the zeros. They're just shouting at me, so I'm going to put C in those. Now I'm going to count the cells. So this is a bigger fleet of battleships. So this is 20 ship segments, and in the top row we have 19. Right, we've got 19's worth of clued ship segments. So in the unclued columns, there is 1 ship segment to find only. Now, what about in the rows? We've got 8, 14, we've got 19 again. So in the unclued rows, in the rows, we've got 1 ship segment to find. I'm not seeing immediately what that means, but there's certainly a difficulty with this 8 clue, because there's only 9 blank segments in column 2. And there's only 1 battleship available. So if this cell was C, the rest of this column would have to be ships, and there would have to be 2 4-cell ships to make that work. So that's got to be a ship segment, which means that is not a ship segment. So this could be part of the battleship or not. Battleship is in this column, we can say that for certain. Right, row 1 has some constraint as well though now, because this has got 6. Yeah, okay. Okay, this is interesting. It's a similar thing to the example, I think. We've got to put 5 ship segments into this 6-cell stretch. Now, what I said, I sort of said it flippantly, but I think it's true, is in the 8 column, we must have the battleship. Because if we don't have the battleship and we try to fill this column with 3's and 2's, we will have too many gap cells. Basically, we're only allowed 1 more gap cell, which means that we either need a 4 here or a 4 here. That's forced. That is forced. So that means in this run of 6 cells into which we have to put 5 ship segments, we're only going to be able to do that using 3s and 2s. We can't use 1s because we'll have too many gaps again, because we've got to have only one gap in the remaining thing. So that means this and this have to be ship segments. This and this have to be ship segments. And one of these is in, one of these is out, which means we can do all of that. Look. Now this one clue is done in this column, so let's put that in case that does anything for us. No, hang on, let's do better than that. That can't be a ship segment, because that would be diagonally touching another ship. So that's out, and now this one has to be in there, which means that's out, which I'm sure is in some way interesting. Maybe. Okay. So this 3, this 2. There was one ship segment to find, wasn't there, in the remaining bits and pieces? Oh, hang on, I haven't even looked at this clue. That's a bit silly of me. There's a 6 clue here that seems to just be fill-inable. Let's put that in. So we can, anything diagonally connected with that, we can CFI. Look, and now column 2 is done, because we've got 2 C segments, so the rest of this has got to be, I don't know how it knew that was going to be that, but now it's changed it again. But anyway, this column is forced now, and we've got the battleship placed. Now also look at this row. This row has got a ship segment in, and we knew there was one ship segment to find in the unclued rows, so all of this can now be done, and the same with this row, which is rather cool. And look, in the columns we've got the same thing. We're only missing one ship segment. There it is. So the rest of this column needs to have C in it, and now the whole of this column has to be C. Otherwise we'd have too many ship segments clued. Now that's got to be in to correct the count. This 2 clue is now done. This 2 clue is now done. This 1 clue is done. And what have we got left to place? We probably need to go... this 1 clue in the bottom is done. This 2 clue has to be done like that. Now, what have we got? No, we've got 3 two ship segment things already in, so that must be a 1 segment. And the only thing we've got, is it this cell is the only, so that cell's got to be a ship, and there it gets completed. Beautiful. Very, very elegant. Now, what I have difficulty telling is how much it mattered about the counting that I did in the unclued rows and columns. It felt very smooth, but it might be the case that if you didn't use that trick, it was a lot harder. Don't know. Have to look at the comments to find out. But another beautiful puzzle, that one from Tyrgannus. So I've got 2 more to do. I think the next one is Freddy. Let's find the rules for this one. This was called Summon, I think. This is it. This is it. Right. So here we have to enter the given set of digits into the grid so that each digit appears exactly once in each region. A bit like Sudoku then. Cells with equal digits cannot touch each other, not even diagonally. That's not like Sudoku. That's like King's Move Sudoku. Okay. Digits in adjacent cells within a row or column form multi-digit numbers, read from left to right or from top to bottom. Digits without neighbours form single digit numbers. Okay. The numbers outside the grid indicate the sum of all such multi-digit and single digit numbers in the respective row or column. Wow. Okay. And then there's a Pemper note. Shading is not required for answer check, but may be helpful for keeping track of which cells contain or don't contain a number. Right, goodness. Okay. So let's just try this one and see if we can do it. Now I'll put that there. I see. Okay, so I might need to do shading here. Oh, right. So I might need shading and Sudoku, but the looks of the tabs I've been given. Let me just click around and see. So if I have the numbers in, I'm not very used to Pemper. Right, so this is a 1 to 3 puzzle. So I've got to put the numbers 1 to 3. Oh, so this region has got to have a 1, 2 and a 3 in it. Oh, okay. So I immediately see that cell's a 2. Because if it was anything... Oh, no, it could be a 1. I was about to say something totally wrong because I'd not really thought about it. But I was about to say that had to be a 2 to meet this criteria for this 2 clue. But if that was a 1 and that was a 1, and these were both single numbers, I guess that would work. So, so I think what I was saying there was nonsense. Ah, no, I see. In fact, I would have got it wrong if I put a 2 here, because I think this 32 is the key. These two cells we know are digits. Now, whatever I put into these is going to form a 2-digit number. Now, if I was to extend, if this was to have a digit in, or this was to have a digit in, I'd have a 3-digit number, or even a 4-digit number in the row. And that's clearly going to be bigger. There's no method of subtraction in this puzzle, so it's going to be greater than 32 if it's a 3-digit number. So this must be the only number in the row, which I think means that's 3, that's 2, and that's 1, which means that's 1 in order to make us have single-digit things. Now, what I would really like to do now is to shade some things in. So I think I've got to do surface. Oh, that works quite well, look. So all of that must be true in order to make sure these are single-digit ones. Now I've got no clue. Oh, well... No, I do know what to do actually, because this 2 clue sees those 3 cells by sort of King's Move Sudoku, and yet I need to put a 2 in that region. So that's got to be a 2, and now I've got to put a 3 in this region, which must go here. And now I've got to put a 1 in it, and right, I don't know that because of the... Oh yes, I do, because this 23 clue, if this was a 2 clue, if this was a blank cell, then I couldn't make the 23 up. So that must be the 1. That's empty. That must be a 2 to get me to 23. This 5 must see a 3 in the row, which must be there. And that's correct. Right. That's very cool. What an interesting puzzle. Now it says there, some an example from the World, might be the World Sudoku / Puzzle Championship 2019 instruction booklet adapted. So this is a puzzle type that's obviously been used in the World Championship before. I certainly don't remember solving it though. If I ever have, that's embarrassing. Right, here's the real puzzle now. So I may get interrupted by a need to read Harry Potter, but I will try not to. Let's have a look at this then. Oh, this looks complicated. It's only 1 to 3 again. Okay, so oh, I'm on the wrong type of entry. These 3 digits here are going to form a number that must, so that can't start with a 3 because that would make it a 300 number. Right, what about these 3 digits then? This must be 1, 2, 3 in that order, because otherwise it's going to be higher than 129. So now we should put a blank cell in there. Yes, okay, I see what's happening. So now in the row I need to add exactly 6 more to 123 in order to make it the correct number, which means that must be a 3 and that must be a 3, and therefore I should hive off the differences between them, or the complicated way of saying greyify this cell. Right, now what do I do? Haven't got a clue. Oh, this 3 clue, if this was a digit, would be higher than 8, so that must be a grey cell. Gosh, this is very unfamiliar to me. Okay. Goodness. Is this obvious what I'm meant to do now? I'm sure it is if you're Freddie Hand. Freddie Hand is one of the world's fastest solvers. But it's not obvious to little old me. I mean, I can see how I could do... Oh, I suppose the same is true for this 16. If that's a digit, that's a 30 number. Right, okay, so then I can see that these 2 squares have to be digits. So this is a 1-2 pair. So maybe I should do centre marking for that. Right, and it's a 1-2 pair. No, I don't need to do centre marking because that's forming a number that mustn't be bigger than 16. So it must be a 12, which then must have a grey cell after it, and there must be a 1 in this column in one of those two cells. I don't know if I know which one, but that must be true. So now, well, now I can see things like the 1 in this region can't be next to this one, so it's in one of those two positions. The 2 in this region is in one of 3 places. The 2 in this region is in one of, oh, we're getting into silly levels of pencil marking now, so I don't really want to do that. I suppose that cell is grey though, by that logic. It must be grey because it cannot be a 1, 2 or a 3. So that's a little point, which means that we've got 1 contributing to our 24 total. And I need 1 in one of those two cells, don't I? But, oh yes, hang on. But this bottom region has got digits in it, so that must be the 1. This is very clever, actually. And now that can't be a 3, so it's got to be 2, 3, 1. And now I can greyify this, greyify this, greyify that, or this is a double-digit number. Look at this, I can place 2 in this region now, because it can't be connected with the 2, so it's got to go there. And therefore this has got to be grey, otherwise there's a problem. And look now, in this column, I haven't got a total of 8 until I do that. So that's got to be correct. I'm not very good at correcting all these pencil marks in this software, but there we go. That's all forced now. 1 has to be in one of the... Oh, so if the 1 was here, this would be 21, which would be quite useful. But one of those two has to be 1. And 3 must be one of those. So this can't be the 3. So the 3 is placed in this region, which gives us a 32, but there's no clue, so that's not really useful. Right. So now I've got 231. So I need to add 4 to that. That's 2 numbers. So that's got to be grey. And both of these have got to be numbers. But no, we don't know what they are. They could be 2, 2 or 1 and 3. I don't believe it. How weird. But we know both of them are numbers. Does that matter for some reason? Oh, I'm getting shouted now. So I'm going to have to pause this in a second. I will try and finish this puzzle really quickly, and then I'll have to record the other bit as a separate slug a bit in a few minutes' time. Okay, let me think. So this region, the cross-shaped region in the middle, it must have a 2 in it. That 2 must be in one of those cells. It must have a 3 in it, and the 3 can't be here or the 24 clue's broken. And it can't be here or the 21 clue's broken. So there's a 3 in one of those two cells. And it must have a 1 in it. And I'm going to say that the 1 can't go there. Because if it did, that would be part of a 12 clue, to which I would need to add 9 in the row, and that's not a valid total when I only really got one cell that I could add to it without making a double-digit number. So 1 in this region I'm going to say is there, which means that's a 2 and that's a 3 and that's a 2, because this 2 can't touch its friend. This is very clever. Indeed, so that's great because we can't have another digit in the cross-shaped region in the middle. This 21 can't be a 3-digit number, so now I need... Oh, this is lovely. Yeah, okay, so now I need... I needed 2 more. I need 2 more. So actually I don't know where this goes. There's a 2 in one of those. That's what we know. Oh, where does 1 go in this region now? Boom, boom. One of those two cells exactly. Okay, so if this was a number, it would have to be a 1, interestingly, and then this would have to be hived off, and I'd have 32, and I need to put a 2 in the column, and I could do that. Wow. Oh, that's I see. Right. If that cell is grey, then how on earth do we make this column work? Because we then have a choice. We can say this is a double-digit number, but if it's a double-digit number, it's beginning with a 1, so we can't get to 34. Or we could try and make this grey, in which case we've got a total of exactly 4, to which we need to add exactly 30, and we can't put 0 into the puzzle. So that cell does need to be, I'm going to say, that needs to be a 1. And therefore this has to be grey. And now I need to add 2 to that in one of those two cells. In one of those two there. And now this cell is not a 1 because we've got the 1 in this region. So, okay, that's probably important. Wow. Oh, I see. So if that was a 2, then I'd know that was a 2 as well, which would be really handy. The 21 is still very much an option for this row. This row we know nothing about. And this row, or this column, is a 46. 6 is a weird number. So that's thinking about the fact we've got to use 1s, 2s and 3s. I suppose we could, in a theory, have 3 2s as the units digits. No. No, how could we do that? We can't do that. We could have 1 2 here, but then I can't put 2 2s in this one region. So this column needs to contain a 1, 2 and a 3 as the units digits, which feels restricted to me. So this 1. Oh, come on. Think about it, Simon. 1, 2 and a 3 is a unit. We know this is a digit, don't we? So if this was a 2, does that mean this has to be shaded? I don't know. I sort of feel like it might do, but I'm not certain. In fact, yeah, okay, how do we get to the right total here? Maybe that's the point. Maybe I shouldn't be thinking about the units digit. I should just be thinking about how do you get to 46? Because it could be 2 20 numbers summed together, or it's got to be a 30 number and a 10 number summed together. Now, if it's 2 20 numbers summed together, that would imply that this 2, I need to make a 20 number in these first few cells, which I can't do. So it's not that. It's a 30 number and a 10 number. Now, what does that mean? This could be the 10 number, obviously. So that would mean this would have to be in. That would have to be out. And then I'd need a 2 somewhere. Plus a 30-something number. Yeah, so hang on. It can't be 20 plus 20. So it's got to be 30-something. Where am I putting my 30-something number? And does that mean this cell here has to be... Oh, this is tricky. This is tricky. I'm not understanding this very well. Really am not. I'm sorry about that. I'm sure that there are many, many ways of doing this more efficiently than I'm doing it. And it's starting to get wearing. So, what is it I'm not understanding here? If this is a 2, maybe that's the way to think about it. If this is a 2, then we know that would have to be unshaded. Now, in order to get to the right total, this would have to be a 20-something number, and then I'd have to add another 20-something number down here, wouldn't I? That feels like it's very close to being nonsense. Or is there a... Oh, I know what it is. No, it's obvious. I'm just not used to this puzzle. It's this one. It's this row. How could that be empty? And the point is that you'd then have to make 19 in the remaining cells. Oh, I'm so silly. Right, so if I'd had that thought immediately, this would have been completely obvious. That's got to be 21. That's out. Therefore, this is finished. And now those two are finished. And now all of a sudden, I've got 3 definite digits to place in this column, because these have all got to be... Oh, hang on. I want to put sort of 1, 2, 3s, 1, 2, 3s, 1, 2s, and 3s. So, now, if that is a 2, this would have to be a 2 as well. This would be a 1 or a 3, and that could be a 1 or a 3 in order to make up my 4 total here. But... Okay, this can't be a 2, because that's going to rule a 2 out of those 2 cells. So this is a 1 or a 3. Where do I put 3? If that's a 3, I'd have to put a 3 here as well. And that won't work. Oh, this is very complicated. But if that's a 3, in this region here, I've got to put a 3 somewhere. And it would have to go there. So I'd have 13 plus 3 is 16. I need this to add up to 30. So that's got to, in fact, be a 1, I think. So now, in terms of my 46 thinking, I now need a 2 and a 3 to add. So this has got to... I can't add 1 and 1 as units digits, because I can't make 4 in the remaining units digits. So that means that this must extend, which means this is not in, which means that's the 2, I think. Oh, hang on. So that's out, I think. So now this is in and must be a 3. So I've now got 14, to which I need to add 32. So we can fill this in, which means that's a 2. And now I need to put 3 in this region. Oh, hang on, let's see. Oh, I need to put 1 in this region as well. Hang on, what's... Oh, I see. No, that's out then. Right, I see how this works. That's now not got a digit in it. That's got to be a 3. That's got to be a 1. And then it's finished. That was awful by me. I'm so sorry about that. And it was predominantly awful. Well, no, it was awful everywhere. That's just an example of how inexperienced with a puzzle type and being COVID-ridden and inept renders me useless. This row, I should have seen immediately that if this was an empty digit, 19 was an impossible total, but I just didn't spot it. And I think that would have made it a little bit of a smoother solve, but I couldn't really... I think there's something you could do very quickly with this 46. But yeah, very interesting puzzle. I would love to know what the time is meant to be for that, but I have to go and read some stories now, so I'll be back to do Eric's puzzle in just a moment or two. Right, I'm back, I've done my reading. So now we've got the final puzzle, which is Eric Fox's puzzle called Square Jam, another puzzle I haven't ever heard of before. I suspect, although I don't know this, that it might be one of Eric's own creations. Eric is so creative, he's always coming up with new puzzle types. So this could be a real original. But these are the rules. We have to divide the grid into square regions of orthogonally connected cells. A number indicates the side length of the square it's in. Region borders may not form any four-way intersections. So I don't want to look at the example too much, but that sounds like we can't have any crossroads created in the grid. So let's find the puzzles here. So this is the example puzzle. And let's see how we can do with this. So let me just check what I've got in terms of... Right, I can drag and click some stuff here. So I can drag between cells like that or along boundaries like that. I don't know if right click does anything. No. No. Okay, so let's have a go at this and see what we can do. We've got a 1. That must be a square, mustn't it? let's a 2, that must come out to there, but then we don't know what it does after that. We don't know whether it goes down or up. A 3 must come to there. Oh, I see. Right, and this 3 must also come to there, look. So in fact, these 3's, strangely enough, I think are joined together. Like that. Now, so now I've got to avoid... Ah, yeah, lovely. Okay, so look at this 2. If this 2 came down like this, it would create a crossroads. And that's what we're told in the rules not to do. Oh, hang on, getting confused here. So that means that this must go up. So it must do that. But I still got to... Oh, right. Okay, here's something odd. So I think that line segment there is forced because, well, how else can we complete a square? But then we have to decide what we do with this 2 by 2 here. Now we could do that with it, but that's going to create a crossroads in the middle of it. So I think we just have to leave that blank. Yeah, okay, and now look at this. That would be a crossroads, so that's got to be these two. This domino must be part of the same square, and therefore it must be part of a 2 by 2 square because it can't be part of anything larger. So that means this is a 1 by 1. Now this junction here, that's going to be a crossroads, so we've got to do that, which makes another 2 by 2. That must be in a 1 by 1. Now I've got to avoid this being a 2 by 2. So that must be like that, which puts a 2 by 2 there. And then we do that. Ah. Oh. And that's not right, apparently. So what have I done wrong there? I thought I avoided. I definitely tried. I promise I did try to avoid all the 2 by 2. All the crossroads, I mean. Where's the crossroads? It must be a crossroads I've got wrong. I don't know. Oh, goodness me. I've not understood this at all. Oh, unless, you know what? I wonder if I was... maybe I'm meant to green the whole of the boundary. Or maybe I'm not meant to green the whole of the boundary. That's not worked. Right, let's try and ungreen the whole of the boundary and see if that makes a difference. And it does. Oh, right, so it was right. It was right. What I'd done wrong is I'd drawn some squares as real squares, putting greens along the boundary, and I was not meant to do that. Right, so don't put greens along the boundaries. We don't need to do that. So let's go to the real puzzle, which is here. I'm going to have to move everything again. So there we go, we've moved everything again. And let's try this one. So the 3 must come out there, look. The 1 has to be there, this one has to be here. This one has to be, whoopsie, like that. The 3 here must come out at least here. Could come out again, but it's definitely coming to at least here. This 3 must go up. Ah, okay. So how does this 3 work? Well, you can see it's got to come to here. But then it's going to bounce into the edge of the 2 unless it actually takes those cells. So that's a 3 by 3. This 2 must take those 2 cells. This cell must be part of a 1. This cell must be part of a 1 in the corner. And now I've got to avoid that line segment. So that means that must come across. But I've got to do the same here. So that must come across. And I've got to do the same here. So that must come across, which means I've got a 4 region there. So that must be a 4 by 4, I think. This 3 must come out to here, look, because it can only take 1 run of 3 to its right. Okay, and now we're stuck. What is it I'm meant to appreciate now? I don't know. I thought I was getting the hang of it on the example puzzle, but now it seems that well, that 2 can't do that shape. I can see that because that will create a crossroads. if I make that shape, that's broken. Right, that's the key. Look, if we do make that shape, the reason this is broken is how do I deal with this bottom corner square? It would have to be a square like that, and that creates an automatic crossroads. So actually, this has got to go down like that, which means that must be a 1 by 1, that must be a 1 by 1. Now I've got to avoid this being a crossroads, so that's got to be in, which means that we've got a square that's at least that bumps into the 2, forcing it to be a 2 by 2. So now that's forced to be a square. Now I've got to avoid this one, so that forces this shape. Oh, right, this is lovely. Right, so because this domino has to be forced, otherwise we'd have a crossroads. If this was a 3 by 3, it would bump into this 3 by 3, but not in a shape that is a square. So we've got to do that, I think, which means that this is now forced to go up to there at least. Oh no, and it's now got to bump into this, doesn't it? Yeah, because these two squares here can't be part of a 2 by 2, so they've got to be part of 1 by 1s. Ah, now look, that would be an illegal line segment, so that's forcing that 3 by 3, so these threes are in the same region. And then, right, what do we do now? Where is the next opportunity for a crossroads? I don't know. Is the short, I suppose that, I see, okay. This cell has got to be part of a 1 by 1, and that means that cell can't be a crossroads there, so that's got to do that, which means it's part of a 2 by 2 at least. In becoming part of a 2 by 2, it bumps into a 3 by 3, so it becomes a 3 by 3. Now this line segment's impossible, so that's got to do that, which means that we've got to do that, which means we've got to do that, and then this 2 by 2 in the corner can't be sort of divided into those small Lego bricks, because that will be wrong. Now this has got to be out, because otherwise we've got a crossroads. This is such a clever puzzle, it really is. That's forced. Now how do we avoid the next? Look, that is a problem now, so that's forced, that's forced, that's forced. That's a 2 by 2 because it can't be any bigger. Make this a 1 by 1. Now look, that's impossible, so that's got to do that. That's impossible, so it's got to be that, which means that's forced, that's, oh, and we've done it. Okay, so that's just a brilliant puzzle. What an amazing idea that is. Is that your, Eric, is that your own creation? If it is, that's wonderful, because it's really, there's some really neat interactions, and it's not obvious, but once you get flowing with it, you can sort of see how you could become quite good at that. I really enjoyed that. I really did. Well, this is why. Everybody watch this video. If you're still watching it now after what must be an hour or so, I hope that you're getting the bug for these amazing, amazing puzzles. And there's one every day. And there's probably hundreds of people competing. They all share their times. You don't have to share your time, but you can. Yeah, it's a lot of fun. So I certainly recommend it. And do let me know if you really did enjoy this video. Let me know as well, because I will try and do them more often. I just hope that you realise that it's going to be a bit painful to edit this so that it makes it look reasonably interesting, or accessible, or in the screen, or on the screen in the right place. Anyway, thanks for watching. We'll be back later with another edition of Cracking the Cryptic.